Hi class. In this video, I want you to go to the packet you got in class. If you don't have the packet, it is on Google Classroom also. So this is day one from Monday, and we're starting the complex numbers unit. So I'm starting on page 1 with this video. So we're talking about imaginary numbers today. And so with imaginary numbers, it all comes from a negative under a square root. That's kind of how it starts. So if we have the square root of -1, this equals I. So that's our imaginary number, okay? And so anytime we see a negative under a square root, you should be thinking that I need to have I in my answer, and I need to take the negative out. So for example, on number 1 on your packet, we have the square root of -9. And so the square root of -9, it has a negative. So we have to take out that -1. So we have -1, the square root of -1 times the square root of 9. Okay? Well, we just said that the square root of -1 is equal to I. So under this branch, we would go to I, and there's nothing more you can do. So that would be the end of your branch. Okay? Now, from the square root of 9, that's one of our perfect square roots. And so the square root of 9 right here, right, we know is equivalent to the square root of 3 times 3, or 3 squared. But the squareds cancel each other out. So the square root and the squared cancel out, and so you're just left with 3. So that's the end of your branch. We then just put the 2 together, and the correct way to write it is 3I would be your answer, okay? And so that would be the answer to number 1, would be 3I. Okay, let's try one that's not perfect. So if it's not perfect, you still need to simplify it. So before break, we had learned how to simplify radicals or square roots. And so let's take a look at one of those. So let's take a look at number 4. Okay, so number 4 is the square root of -80. So again, the first thing you should be thinking is I need to take out that negative. That's the very first thing. There should be a square root of -1, and then you still have the square root of 80. Okay? From the square root of -1, that equals I. So we're at the end of that branch. We have I. The square root of 80, however, is not perfect. 81 is perfect, so we were close, but not quite. From here, you need to choose factors where one of the factors is one of those perfect square roots. And so those perfect square roots, remember, are 2 times 2, so like the square root of 4, and that equals 2. The square root of 9, and that equals 3. The square root of 16, and that equals 4. Square root of 25, and that equals 5, right? So these are all our perfect ones. And so we want to say, okay, 80. Well, I know that 4 goes into 80, but is that the highest? And so you always want to try and pick the highest because 4 is kind of low. So 80 can also be divided by 16, and 16 also is a perfect one. And so in this case, we're going to use the higher one. So the square root of 16 times the square root of 5, because 16 times 5 is 80. But the square root of 16 is one of those perfect ones. And so that one goes away, and we're left with 4. And that's the end of that branch. We then double check this other branch we made, which is square root of 5, and make sure that we cannot take out another perfect, right? We want to make sure that we can't put another one of these in equally, okay? And in this case, we cannot. The square root of 5 is the end of that branch, and so we're going to circle that. And then we put our branches together, okay? The end of the branches. So we're going to have 4I on the outside, and then on the inside, we still have square root of 5. And that would be your final answer here. So we combined imaginary numbers with simplifying radicals in this equation. Okay? The last thing I want to show you in this video is if we need to solve for the equations by taking the square root, when we also get a negative and end up with imaginary numbers. So that's the last thing. That's the last thing on page 1. So if we go ahead and take a look at number 7, for example. So number 7 on your packet says x squared plus 81 equals 0. And in order to solve for this, you want to solve for x. And so we need to get x all by itself. And so we're going to move over the 81 and start isolating x. So we're going to subtract 81 from both sides. And so we get x squared is equal to a negative 81. We still don't have x by itself. There's this x squared there. So in order to get rid of a squared, the opposite is square root. And so if you do it to one side, you have to do it to the other. So I'm going to square root both sides of my equation. From here, the square root and the squared cancel each other out, and so you're left with x over here. On the right side, you should notice that we have a negative under the square root. And so since we have a negative under the square root, your first thought should be, let's take out that negative 1. And then we still have the square root of 81. Well, what is the square root of negative 1? We just talked about that. The square root of negative 1 is I. And then what's nice about the square root of 81 is that's one of our perfect ones. So this breaks down into 9 squared. And again, if I take the square root of a squared, it goes away. And so I'm just left with 9. And so I put those two together. And so x equals 9i. Okay. That's your final answer. Let's do one more, and then you can go ahead and practice on your homework 4. Let's do number 8, because 8 has a number with x squared. So we have 2x squared plus 9 equals 1. And so it's the same process. We still want to get this x all by itself. So we need to unravel it, and we're going to subtract 9 first. So we get 2x squared is equal to a negative 8. Right? There is a coefficient, which means there's a number in front of your x squared. And so we need to divide that. We need to get rid of that. So we need to divide both sides by 2. And so we're left with x squared equals negative 4. Now the only thing left is that squared. And so the opposite of squared is square root. So we're going to square root both sides. The square root and the squared cancel each other out, and we're left with x on this side. And then over here, we have a negative again. So we should be thinking, okay, I need to take out the square root of negative 1. And I also still have that 4. But the square root of negative 1 is I. And in this case, the square root of 4 is perfect, and that's 2. And so then I put those two together, and I'm left with 2i as my final answer. Okay, go ahead and take a look at the homework and start the practice problems that have you simplifying the negative square roots and solving these equations. And I'll make a video for the next page. Thank you.